For your warm-up today, you have to find the value of each variable and write your answer in simplest radical form. So we're going to look at this triangle here, and this is a right angle. So we know it's either 45, 45, 90, a 30, 60, 90, or a right angle. And I know since both of these two are the same, then it must be a 45, 45. So I put 45 degrees here and 45 degrees here. Now when we solve these, we'd say 45 is equal to A, and opposite the 90 is going to be an A radical 2. So I know the side that is opposite the 90. This side length is 5 radical 2. So I'm going to put 5 radical 2, A radical 2 equals 5 radical 2. And in order for those two sides to be equal, I need this to be a 5. So I know that A is equal to 5. And that's good because then I can say, well, opposite the A, or opposite the 45 is 5. So X is 5 here, and since it's opposite the same side, 45, opposite the 45 is 5, opposite this 45 is also 5. Moving on to your second one, this is a 30, 60, 90, 30, 60, 90. So I know I'm going to write down opposite the 30 is A, opposite the 60 is A radical 3, and opposite the 90 is 2A. The one side that I do know that they give me is opposite the 90. So I'm going to say 2A equals 8. Divide by 2 to figure out what A equals, and that is 4. So that's going to help me solve or figure out what's opposite the 30 and the length opposite the 60. So since A equals 4, opposite the 30 is 4. So I would say X equals 4. And then I would fill in, whoops, there's a 4 there. A radical 3 equals 4 radical 3. Because if A is 4, I just fill in a 4 there, and that's my answer. So opposite the 60 is also 4 radical 3. We're going to talk about our trig notes today. We're going to talk about sine, cosine, and tangent. And an easy way to remember these is something called SOHCAHTOA. The S stands for sine, so this is sine, and sine would be opposite over hypotenuse. So I like to put opposite over hypotenuse. And cosine here, so I can put cos, here's sine, abbreviated, is adjacent, I'll just put the whole word, over hypotenuse. And tangent, we abbreviate with just tan, is opposite over adjacent. So when I'm looking at this first sine ratio right here, figure out the sine, I have to know what angle we're talking about. We have a right angle. So the reason, when we use this, or the time we use this, is if we have a right angle and we know one angle, we can figure out any of the sides. So I'm going to say sine of the angle, which is A, equals opposite, and this side is opposite. When I'm talking about opposite, I'm talking about the side that's opposite, over hypotenuse, and S is my hypotenuse. So I like to go back and write it in so I know according to this angle right here, this side right here is my opposite. This side right here is my hypotenuse, and that is, no matter where the angle is, that's always going to be my hypotenuse. And this side, side W, is going to be my adjacent because it's the missing side. So I like to get my opposite, this side labeled, and this side labeled, and then this is my last side. So the sine of A is opposite over hypotenuse. So opposite is M over my hypotenuse, which is always right here, opposite the right angle. Whoops. Now I go to my next one. And I would say cosine of A. So I'm using the same angle. And let's say we want to figure out, they give us the values of W and S. But we want to find A or something like that. They'll give you one of these three if they're using cosine. So leave angle, adjacent side, or hypotenuse. So I would say the cosine of A is equal to adjacent over hypotenuse. This is my adjacent and this is my hypotenuse. So W over S. And then the last one is tangent of A. So you're talking about tangent of this angle is opposite over adjacent. So I'd say opposite over adjacent. So M over W. Now we're going to work on setting up some triangles. We're just going to set up today, and then tomorrow you're actually going to put in your calculator and do the work. So we have the first one, they're talking about this angle right here. So I would go through, and I always label my sides first because I think it's easier. So I would say, okay, according to this angle, 117 is opposite. So I'm going to put an opposite here. And this 125 is my hypotenuse because it's opposite the right angle. So I'm going to write SOHCAHTOA up here to kind of help me. SOHCAHTOA, something you need to memorize. So I would say I have opposite and I have hypotenuse. So which one of these has opposite and hypotenuse? Well, it's going to be sine, has opposite and hypotenuse. So I would say the sine of x equals opposite, which is 117, over hypotenuse, which is 125. The next one, I'm looking at this angle right here, and they give me the hypotenuse, and I know that because it's opposite the right angle. And this one, this side right here would be my opposite because it's the side opposite that angle. So this has to be adjacent. So I'd put adjacent here. And I would say, okay, which one of my trig functions gives me adjacent and hypotenuse? And it would be cosine. So now I'd say cosine of x equals adjacent over hypotenuse, so 48 over 73. Then we have the tangent, or sorry, we're not supposed to know that. Then we have this angle right here, 24, and we have opposite, and we have adjacent, and we don't have hypotenuse, so I'm not going to use this one or this one because it has an H in both of them, so it has to be tangent. So I would say the tangent of 24, the angle we're talking about, is equal to opposite over adjacent. So 9 over x. And then you just put in your calculator, and we're going to worry about that more tomorrow. So I'm going to go up here and I'm going to practice some more. Actually, I'm going to leave that so we can see our SOHCAHTOA. And I'm going to go through before I do anything, and I'm going to label the sides. So according to this angle, this is opposite, and this is adjacent. According to this angle, this is opposite. Oh, this is adjacent, and this is hypotenuse. So I'm labeling both sides because we need to find both A and B. So we're going to have two different setups here. This is my angle, so this is opposite, and this is hypotenuse. I'm going to move this down, or move it up a little bit. And I'm actually going to rewrite SOHCAHTOA so we can always reference back to that. SOHCAHTOA. And looking at this first one, we have adjacent and opposite, so I'm looking at adjacent and opposite right here. So we have to be using tangent. So I'm going to put tangent, oops, the tangent of 50 equals x over 13. And then number 2, we need 2 of them because we're looking for A and B. So I'm going to solve for A first. I know adjacent and I know my opposite. I'm sorry, I'm going to find A first, so I have to use adjacent and opposite. So that would be the tangent again. So tangent of 57 equals 14 over A. And I know I have to do opposite over adjacent because that's the order that TOA is written. And then we're going to do another one, and we're going to find B here. So I use opposite and hypotenuse. So I look over here, opposite and hypotenuse would be sine. So I'd say the sine of 57 equals opposite, which is 14, over hypotenuse, which is B. That wasn't written very well. There. So we just have 2 different problems to find A and B. Number 3, I'm going to use, I have to find C and D. So I need a label. Go back and label this. This would be my adjacent side, according to this angle. So I'm going to use opposite both times. So I know that I'm not going to use any cosine because opposite and opposite are in those two. So first I'm going to find C. So I have opposite and adjacent, so that would be tangent. So I'm going to say the tangent of 41 equals opposite 17 over C. And then I'm going to do the next one, and I'm going to use, so I just used tangent. I'm not using cosine because I need a O, because I know O is 17. So I'm going to use sine. Sine of 41 degrees equals opposite over hypotenuse, which is D.